We've all been there, trying to log into a new website for the first time or buy the newest Amazon deal, when suddenly you're prompted with a weird request staring back at you. A checkbox with the label, "I'm not a robot." Now, many of us might click this box and move on with our days, but also many of us might sit there and ask ourselves, why on earth should I prove myself to a computer, a robot themselves, that I am a robot or not? And couldn't an advanced AI tool easily pass this test as well? Well, as it turns out, both those questions have already been answered, and the real desire in this task lies in what comes next, the CAPTCHA. CAPTCHA, which officially stands for Completely Automated Public Turing Test to Tell Computers and Humans Apart, kind of a mouthful there, originates all the way back to brilliant computer scientist and mathematician Alan Turing. Turing and his colleagues were arguing whether computers could ever reach the same level of human intellect. To test this, he created a project called the Imitation Game, in which an interrogator would ask questions to both a computer and a human in a text-only chat, and if the interrogator could not find the difference in their responses, then the computer had passed the test. This imitation game, or Turing test, as it later came to be known as, has lived on to this current day and age, and has evolved into more practical uses now. Based on this early test, with this knowledge in the early 2000s, to defend against automated programs attacking websites or networks, Luis von Ahn created the CAPTCHA. The purpose of the CAPTCHA is to generate tests that humans can easily pass, but will baffle computers and bots, limiting cyber attacks and creating greater security on the internet. Originally, CAPTCHA started off as jumbled text, where the human had to type in the desired characters before being able to proceed. Then, later evolving in their life to include very familiar 9-square images you're seeing on the screen right now. A process in which the user needs to select a certain subset of images out of the 9 squares, such as all the squares that contain a bus, a street light, or any other sign on the road. While this effort to add security may seem harmless, computers usually already know whether you're human or not before clicking that little square. When you click the "I'm not a robot" box, the site sends a variety of information back to the source, typically Google, such as your mouse movement around the screen, cookies, and device history, which prove to be very telling whether the user is a bot or not. So at this point now, you might be asking yourself, if the computer already knows I'm a human, why can't I just proceed to use the site normally? Well, turns out you can, as long as you provide them one piece of information, the CAPTCHA response. For some background on this, in order to create a successful machine learning algorithm, you need 3 key features: data, features, and algorithms. For this video, we'll stay on the data portion. All AI needs a starting point that it can compare future responses to. So by providing a diverse data of correct solutions, whether it's the correct set of letters in a scrambled image, or the right squares that contain a stop sign in it, the data can be used as a parameter, as a feature, to train the algorithm, which will then be able to distinguish anything the model was trained with, creating a powerful AI tool that can easily discern and interpret new data. Originally, when the CAPTCHA was first introduced, this data set was not being used at all and being wasted. But Luis von Ahn, the creator of the CAPTCHA, adjusted the prompts to give the users to give them more unscannable text from old books and newspapers. And soon, with this model being created, the entire New York Times archive was digitized. Over 13 million articles dating back to 1851. Over 170 years of text. While this feat is very impressive, companies have continued to push the boundaries of CAPTCHAs to exploit users to do their heavy lifting and data collection. And not only does this exploitation of users fly under the radar, biases often arise. The most common type of bias who rise with image CAPTCHAs is sampling bias. Because many of the image CAPTCHAs are intending to train AI for self-driven cars, they need a multitude of data and an image recognition for signs, other cars, and pedestrians. This data can obviously be biased, be taken from places where images are more available, leading the models to be less predictive in underrepresented areas. Other forms of bias can be seen in data collection too, such as measurement bias, where people with visual impairments are asked to perform the same CAPTCHA tasks as everyone else, despite their impairments. Overall, this discussion relates to the real issues surrounding CAPTCHAs today. They aren't just simple security measures, they're tools used to crowdsource data collection and train AI models, often without users realizing it. Think about it this way. Now, every time that you select one of those little stop signs or a bus in those little images, you're not just passing a test, you're labeling data for companies, often to train AI systems like those used in autonomous driving. These companies get invaluable data at no cost, and in vast quantities as well, as millions of people per day are doing the exact same CAPTCHA tasks. So, the next time you solve a CAPTCHA, remember this: you're not just proving you're a human, you're also working for free.